Hello friends, today we are going to learn the topic performance of transmission line for the subject power system 1. I am Dr. P.V. Thokar, Department of Electrical Engineering, Sanjeevani College of Engineering, Kopargaon. So students, our today's point is classification of overhead line. Classification of overhead transmission lines. So in this particular point, classification of overhead transmission line, basically there are three types of transmission line which is classified as short transmission line, medium transmission line, and the last one is long transmission line. Now if you are considering the first point, which is short transmission line, the important point to be noted for this particular point is this short transmission line is used up to the distance of 50 km and voltage of below 20 kV. So short transmission line is basically used up to 50 kilometers and used for the voltage below 20 kilovolt. This point is to be remembered. In this particular case, due to the smaller length and lower voltage, so in this case voltage is less and length is also small. So because of this property, the capacitance effects are small and can be neglected. So due to this, capacitance effect is small and it can be neglected. It is neglected. Therefore, while studying the performance of short transmission line, only resistance and inductors of the line are taken into account. So only resistor and inductor L. So only R and L factors are considered for the transmission line and capacitance part is neglected. Now second point is related with the medium transmission line. Medium transmission line. Now point number 1 to be considered for this, the very first is length up to 150 kilometer. From 50 kilometer to 150 kilometer, this is the range of the medium transmission line, and voltage is greater than 20 kilovolt and less than 100 kilovolt. So for medium transmission line, the distance is from 50 to 150 kilometer and the voltage range is beyond 20 kilovolt and less than 100 kilovolt. Now due to the sufficient length and voltage of the line, capacitance effect is taken into the account. Now as we know that R is equal to rho L by A, as this line is having sufficient length, so when the length is increasing, resistance also considered and it is increasing. So due to this sufficient length of the medium transmission line, capacitance effect is taken into consideration. Now for the purpose of calculation, distributed capacitance of the line is divided and lumped in the form of condensers shunted across the line at one or more points. So in case of medium transmission line, while calculating the performance of the transmission line, we have to consider the capacitance along with resistor and inductor. I hope that you have understood this particular point. Now coming to the last point, that is point number 3, long transmission line. Now if you consider the long transmission line, in this particular case, if the length is more than 150 kilometer and if the line voltage is very high, if line voltage is very high, that is greater than 100 kilovolt, we are considering this line as a long transmission line. For the treatment of this particular long transmission line constants are considered uniformly distributed over the whole length of the transmission line, and rigorous methods are generally used for the calculation. So this was related with the topic number 1, classification of transmission line. Now we are coming to the next topic, that is topic number 2. Topic number 2 is related with very important terms, and let us consider the first term as voltage regulation. Voltage regulation. Now I will tell you the definition first. What is voltage regulation? Generally, when a transmission line is carrying the current, of course there will be the length, as we already written the formula, R is equal to rho L by A. So there are significant factors like length, cross sectional area, and resistivity or specific resistance of the transmission line. So there will be the voltage drop in the line due to the resistance and inductance of the line. The result is that receiving end voltage, that is if you consider the line, this is sending end voltage and this is the receiving end voltage. So receiving voltage of the line is generally less than the sending end voltage due to the voltage drop, right? And this line is expressed as a percentage of receiving end VR and is called as voltage regulation. So this drop Vs minus VR is generally in the percentage is expressed as a voltage regulation. So if we define the voltage regulation, the difference in the voltage at the receiving end of the transmission line between the conditions of no load and full load is called as voltage regulation. So in terms of, if you write the percentage regulation formula, percentage voltage regulation, the formula can be written as sending end voltage minus receiving end voltage divided by receiving end voltage into 100. So this is the formula for percentage voltage regulation. Obviously it is desirable that the voltage regulation of the transmission line should be low. So if we are considering the any particular regulation, so regulation should be as minimum as possible. Regulation should be as minimum as possible. So this is related to the point number 1, voltage regulation. And we are moving to the second point. Second point is also very important, that is called as transmission efficiency. transmission efficiency. Now we know that if you consider the simple formula of efficiency or normal formula of the efficiency is output divided by input. So it can be written as output divided by output plus losses. Now why I have written this part? Because input is equal to output plus losses, right? We have three parameters, is input, then loss, and then output. So output is input minus loss, and input is output plus loss. So same thing is written over here, and in terms of transmission line we can write output voltage as receiving end power, divided by input as sending end power, and if you are considering the percentage efficiency, multiplied by 100. So for percentage efficiency of transmission line can be written as VR IR cos phi r divided by VS IS cos phi s into 100. So where VR, IR and cos phi r, so these factors are receiving end voltage, receiving end current, and power factor, receiving end. So that's all for this particular today's point. Thank you.